Greetings. Today we're going to discuss electron configuration. You have already learned a lot of background information. Now we're going to finally get to write the address. Quick review. Principal energy levels are 1, 2, 3, 4, 5, 6, 7. These are also the quantum numbers. Sublevels. A sublevel, remember, is a collection of orbitals, which I can represent by S, P, D, or F. And finally, the orbitals is the space where you can locate 2 electrons, or 1 electron, or no electrons. So it is just a space where electrons live. Remember the analogy of the hotel, 2 people per room. All right, so in the S, remember we find 1 orbital. The P contains 3 orbitals. The D contains 5 orbitals. And the F has 7 orbitals. Okay, forget that one. All right, so 7 orbitals. Now, the important thing to remember is that only 2 electrons can go in each one of the orbitals. And remember that they have opposite spins. Opposite spins. Alpha, Pauli, and Hund's rule. Make sure that you review those so that electron configuration writing becomes easy. Alright, so I have the periodic table here, just an outline. It would be a good idea to pause. I'll move to the side, and you can go ahead and draw this box so that you know, these boxes, so that you know how the blocks go. This is the S block. This is the P block. This is the D block, all of these yellow ones, and these right here are the F blocks. So, now you have the blocks, and now we're going to take this and put it in the context of the periodic table. Here's another representation, and I realize that this one is a little fuzzy, but notice that it has the periods here. Period 1, 2, 3, 4, 5, 6, 7, and then the S block, the D block, the P block, and the F block. That would help you to be able to write the configurations. Now, I'm going to take this periodic table, and I'm going to go ahead and put the numbers that you need on them, and I'm going to start out with here the energy levels. 1, 2, 3, 4, 5, 6, and 7. Then I'm going to come over here to this side, and I'm going to say 2, 3, 4, 5, 6, and 7. Now, notice that 1, there's 2 atoms that can fit electrons in the first energy level, only 2. That would be the 1s. Now, I'm going to go ahead and write the numbers here. The levels, remember I said in the beginning that there's an overlap of the energy levels. So, this would have a number 3, 4, 5, and 6. Now, over here, this is the F block. I'm going to put a 4 here and a 5 here. And remember that it is the F block. This is the S block. Again, this is the P block, and this is the D block. Now, we're ready to write electron configurations because it's very simple. All that you have to do is to write the configurations the same way as you read a book. You read a book from left to right and from top to bottom. And if we read the periodic table like this, we will be able to write electron configurations very easily. I'm going to start over here to write a couple of electron configurations, the simple ones. So I'm going to write hydrogen, hydrogen right here. It is in the first energy level. The electrons will be found in the first energy level, sublevel S. And how many electrons would I find there? 1, because hydrogen only has 1 electron. So I'm going to place the 1 electron up here as a superscript. Then I'm going to go ahead and read He. So helium. Helium is also in energy level 1, right here. And there are how many electrons in helium? Well, atomic number 2 tells us that there are 2 electrons in a neutral atom. So I'm going to write again, OFBA requires that I start from the bottom up. It's going to be in the first energy level, S, and there will be 2. Next, I'm going to go ahead and write lithium, and lithium will read, we're going to start from the bottom. OFBA tells us to do that. 1, S, 2, over there. Now I'm over here. 2, S, there's only 1 electron, 1 more electron, so 2, S, 1. And this is kind of confusing here, so don't mind it. So I'm going to stand aside, and I'm going to show you, I'm just going to read some electron configurations. And I'm going to use this handy little tool to show you the path. So let's say that I want to write the electron configuration for Fe. So that's where I'm going to stop. Notice, I'm going to start at the top, and this is Fe right here. So I'm going to say 1, S, 1, I'm going to count the boxes, 2, 2, S, 2 boxes, represents 2 electrons, 2, P, 6, 3, S, 2, 3, P, 6, 4, S, 2, 3, D, 1, 2, 3, 4, 5, 6. Simple as that. And I'm done. I have completed writing the electron configuration, or at least saying the electron configuration. We would have to write it all out. All right, so let's talk about writing notations. There are 3 ways to represent it. I just wrote the electron configuration. But there's also other ways to represent the electrons. One is orbital notation. The orbital notation is where you show the little boxes. So let's try to write an electron configuration for magnesium. So when I see magnesium on the periodic table, I know that it has 12 electrons. So the total number of electrons that I'm going to need is 12. So I put this little periodic table in order for us to follow. Later on, you're not going to have those sublevels written on the periodic table, but you'll have to know that this is the S block, this is the D block, this is the P block, and this is the D block. So I want to write the configuration for magnesium, 12 electrons, so I'm going to say 1, because remember there was a 1 here, and a 2, and a 3, and so on. 1, S, 2, there are 2 S's. 2, S, 2, so I'm going to write here for electron configuration, 1, S, 2, 2, S, 2, 2, P, count these, 2, P, 6, then 3, S, 2, and I'm done. The electron configuration is written. Now, check ourselves to see if we have the right number of electrons. 2, 4, and 6 is 10, and 2 is 12. We have 12 electrons, and we have given them an address. We know where those electrons reside. Now, I'm going to do the same up here with orbital notation. So I'm going to write one s at the top, and I know that the s orbital has only, or the s sublevel has only one box, or one orbital. And then I will write 2s. I know it has one orbital. 2p. And I don't have to write the boxes all first, but I've done that to this point. And I know I have 1s2. So one is going to come up and the other one's going to come down, opposite spins. 2s, 2p6. Remember, the order is 1, 1, 1. That's 3, 4, 5, and 6. And now all I have left is the 3s, and that has one box, and it has 2 electrons. Finally, I'm going to tell you the noble gas configuration for magnesium. Noble gas configuration for magnesium is, here's what we do. We simply look at what is the previous noble gas. The previous noble gas is Ne. So just for the sake of explanation, I'm going to write the noble gas configuration for Ne. Very quickly, Ne is 1s2, 2s2, 2p6. And now I'm going to write the configuration for Mg. Once again, 1s2, 2s2, 2p6, 3s2. Notice that this part is exactly the same. So all I do now is simply say, I can use the neon core. So ditto neon. So I'm going to write Mg's configuration, ditto neon. So I do neon core, and then 3s2. So what I'm saying that up to this point, it is exactly the same as neon, but then we have the 3s level. All right, I know this is a little difficult, but with practice, you will get it. And you will have aha moments. I'm going to give you one right now. Take a look. Remember that we had said, this is the S, this is the P, this is the D, and this is the F. We had said that the S sublevel had one orbital, and one orbital only. The P sublevel has 3 orbitals. The D sublevel has 5 orbitals. Oh, I can make that long enough. Let's make that. And the F has 1, 2, 3, 4, 5, 6, 7. Okay? Now, notice that we know that we can put 2 electrons per orbital. So that means that the total number of orbitals is, if it's 1, we can put 2 electrons. If it's 3, we can put 6 electrons. 2 electrons, 6 electrons, 10 electrons, and 14 electrons total. So here's the aha. Look at this. And take a look at our friend Mendeleev's intelligence. Just amazing. Look, how many S boxes do you have in the S block? 1 and 2. Because this guy up here is an S as well. How many in all of these have 2, right? This is the S block. All of these, 2 boxes. The P, 3 orbitals, 1, 2, 3, 4, 5, 6 electrons. 6 boxes, 6 electrons. The D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow! 10 electrons is how many fit in there. And finally, in the F, if we count, there are 14 boxes. So as we add electrons, we add them to the correct orbitals and the correct energy levels. All right, so now what I would like you to do is to write the configurations for the first 10 elements in the periodic table. And then challenge yourself by writing the configuration of silver. And I will see you in class.